So today we're going to be discussing Amazon Sagemaker. Amazon Sagemaker is a microservice created by Amazon that lets you, as it says right here, build, train, deploy machine learning models at scale. It's fully managed, so Amazon takes care of the underlying instances that run the machine learning model. And today we're going to be going over a tutorial on how to make a very simple machine learning model with Amazon Sagemaker. So to start, it looks a little bit complicated, as you can see on the side. It could be a little bit overwhelming, but we're going to simplify it. So we're going to go straight to notebooks and notebook instances. The first thing we're going to do is create a notebook instance. A notebook instance is essentially an instance we create to use Python to communicate with with Sagemaker and build the algorithm however we want. We're going to be using Jupyter when we create it. The first thing you're going to want to do is create a name. As you can see, I've created one before, but we'll just name it Project 1. Because we're just doing a demo, we don't need anything too big or too strong. We'll start with the simplest and smallest instance type. Here we want to do Amazon Linux 2, Jupyter Lab 3, which is just the most recent one. For IAM role, here you can create a new role. This will help you create an Amazon IAM role that works with any S3 bucket and gives you full access automatically. So you can create the role here. As you can see, it created the role for this specific instance. After that, you can leave all the settings as they are. We don't need to mess with the network, or we're not using any GitHub repositories. And you can create some optional tags, but we already have the name up here, so we don't need to create those. So we'll create the notebook instance. As you can see, we successfully created it. We're still in our notebook instances here, and all we're going to do now is wait for the instance to come up. Now that our instance is up and running, we can open it in Jupyter Lab so we can begin working with Sagemaker. This can take a second, but should be up any second now. So the first thing it's going to have you do is choose what language you want to work with. I'm going to be working in Python 3 for this tutorial, but feel free to choose any language you like or anything that's supported here. Here it is now, the file we'll be working with. We can rename that just by saving the notebook, and I'll name it the same as our instance. Doesn't matter what you do with the untitled. So the first thing we're going to do is we're going to be downloading something called SHAP. Now, SHAP is just simply used to, it's a library that we're going to use to visualize our data and display it in a way that we can easily understand using graphs or charts. So we're going to run that. It's going to take a second to install, so I'm just going to pause the video until it's done. Once it finishes downloading, you should see the following message here. As you can see, it says you may need to restart the kernel to use the updated package, which is absolutely right. We're going to use a simple script to do that. This will just restart the kernel for us. Click play here. We can see by this message here that it successfully restarted. Now we can actually begin working with the data. So we're going to be using SHAP. As you can see from this code, which I'll explain a little bit, we're going to be taking the data set. We're going to be making it an easy display format using the display method, which is part of the SHAP library. Then we're going to be taking that list of the features that we're going to be using to train the data and just listing it out for us. So these are the features we're going to be using to train the algorithm to try to predict whether someone makes above or below $50,000. That's going to be the main point of the algorithm. After that, if you want to be able to display the data in a way that makes sense to you, or just to be able to view it for your own benefit, understand it a little better, you can use or study some of the features of SHAP to be able to do that. Here I'm just listing out in a column some of the information about the census information. I'm also displaying the different points in histographically, just to have a visual for us to understand. Now what we're going to do is we're going to split the data set into a training data set and a testing data set. As the names imply, the training set will be used to train the algorithm using this information, and the testing set will be what the algorithm is testing against to see how well it performs. We're going to be doing an 80-20 split, which is typical for a machine learning algorithm, with 80% being used for training and 20% being used for testing. We'll do that with the following script. There won't be an output for this line of code, but it should finish instantaneously. After that, we want to take the training data set, which is now 80%, and take 25% of that for validation. So what we're going to do is we're going to do that with the script. As you can see, we're taking the training data set, we're splitting it into 25 to make that the validation set. Now we're going to use the pandas library just to create 3 tables of these training, testing, and validation data sets, and then we'll be able to view them right after that, so it'll be easy for us to understand. Okay, now if we want to view what we've just done, we can simply write train. Here's the training set. As you can see, it's a very large number. If we write test, we can see the test set. It'll be smaller, of course, 20%, and then validation, which was made from 25% of the training data set. It's about the same size as the test data set. We've officially finished splitting our data set into the different amounts we want for training, testing, and validation. But now we want to save those files as CSV files and transfer them to S3 where they can be used by SageMaker. So the first thing we're going to do is just save them as CSV files. First the training and then the validation. We don't need to do that with testing just yet. Here we go. As you can see, there's no real confirmation here, but if you look on the left-hand side, you'll see that the train CSV and the validation CSV were created, which is confirmation that they were done. Now we want to move those files to S3. We can do that by simply dragging or dropping, but it's much easier to do that programmatically, just to make sure everything goes to the right spot, and then we can view that in S3 later. We'll be using this script just to save it in the appropriate bucket and folder that we want. The folder will be the prefix that we set, which is right here, and then inside that prefix we'll have another folder called data, where we'll save the validation and training CSV files. Once that's done, we can take another script to confirm that those files were saved into S3, and then we can actually go into S3 and confirm that for ourselves as well. This script will just show us that the files were created in S3. As we can see, they were created in S3, but if we want to confirm that ourselves, we can go back to the AWS console, open up S3, Here we see the SageMaker bucket that was created. This is the default SageMaker bucket. Just like the script says, we're going to have our prefix here, which is already set for us, but you can change the name to whatever you like. Then we go to our data folder, where we'll find the two CSV files. Now in this step, we're going to be training our SageMaker model. In general, what people would do is they'll test out different models to see which one works best for their specific use case or data set. But for us, since we're only just starting, we won't need to do any of that. We're just going to use SageMaker's default algorithm called XGBoost. We'll be using this script right here to initiate that. The only thing that we actually need right now is to import SageMaker. These are just confirming that SageMaker was imported properly by printing out the region and the role for our SageMaker instance. As you can see, we successfully printed out the region and the role. So now we can begin working with SageMaker. What we're going to do next is create a SageMaker estimator. An estimator essentially sets up the SageMaker training job. We define the parameters and the framework we're using before we run the training job. And we're just going to do a very bare bones version of this, only adding the necessary things to run it. So we'll use the following script for that. So as you can see here, this line of code will define the S3 bucket. Then we're going to retrieve the XGBoost image from image container that acts as the algorithm. We're just printing that out to help us confirm that we got what we wanted. And then this here will set the parameters for the instance that will be running the job programmatically. We'll set an instance count, the instance size, volume, everything we need. There's much more that you can add to this, but as I said before, we're running a very bare bones model just as a demonstration. Okay, as you can see, it was printed, which means it worked out well. Now we're going to set something called hyperparameters. These define how our model will learn from the input data to predict the outcome we want. They're important to making the model work accurately, but they have a high learning curve. I suggest that you look at the documentation for this on its own. AWS has fantastic documentation for XGBoost, but if you choose to use a different model, you can look at the separate documentation for that too. Now we're going to set the input for the training session using the pathways to S3. These are the files that we set from before, the training and validation inputs. And finally, we're going to use the fit method to train our model. This is going to be the longest part. Training the model takes a long time, but I will just pause the video while it continues. Okay, we've finished training. Likes to remind you how much it bills you for the training you did, but that's no problem. Now we can download the training reports and assess for any problems. We can look for any errors or overfitting, things like that. If you're familiar with machine learning models or just want to practice, this is a great way to do that. So the script we're going to run to download that. We're going to start by just printing the report, and then after that, here we go. These are all the reports we generate. Now we're going to download these reports to AWS S3 to our bucket. It'll show you that it downloaded every single one. Now I can go back to S3 here and take a look. we'll go to our prefix just as we did before, and we can take a look at X model boost. Here is our prefix, SageMaker XG boost, and here we'll see the folders with our output. We can go in and view the files as we like, but I'll do that at a later time. What else we can do is we can run a script to get an HTML report, training report, and this just is a really simplified version of what happened. It'll give you a distribution, how much loss you had, information about your matrix. It'll even give you an evaluation and accuracy score, what you can do to improve it. It's very thorough. We can also download a report on the instance details, how much of our instance we used, if there was any bottlenecking, things like that. Also a very, very useful tool. We can see what happened in our instance, if we need more power, whatever we need. We have officially trained our model. It should be working and ready to deploy against our test set. So that's what we're going to do now. With the following code. We're defining an instance count and instance type again because we're deploying it in an endpoint that we're going to be using for the model. Okay. Once that runs, you should see you will see that it finishes running once an exclamation point appears. This can take a minute. I'll show you the exclamation point once it finishes, but we'll pause it for now. Now, as promised, as you can see, once it finishes loading, you'll see the exclamation point right here. That's your sign that it's finished deploying. Now we can finally evaluate the model against the test dataset. For our final step, we're going to be using this script here. We're going to set up a predict function that tests the model against the test dataset. The rows argument can be changed if you want to do a batch or make it go faster, but it directly affects how much of your instance capacity you'll be using. So first we're going to create an empty set where all the predictions of the model will be stored. We're going to split the data set into smaller, more manageable subsets, and then we're going to iterate over each split, making predictions on each subarray. This will help it go faster. Then, of course, we're going to return the model's predictions. All right, once that's done, we will obviously want to display these predictions, so we're going to run a quick script to do just that. Here we can see how the model learned. You'll see the following histogram with the y-axis displaying the number of predictions and the x-axis displaying the prediction accuracy. These are in a float number. We need to establish a cutoff where we decide that the model predicted accurately or didn't predict accurately. This is called establishing a true-false binary from this float. We're going to do that with the upcoming code. So we're setting here a cutoff of 0.5. This is just arbitrary but intuitive. Anything above 0.5 will be seen as a positive prediction in the model, and anything below will be seen as falsely predicting. Then we're going to generate text reports of the classification matrix. This is called a confusion matrix as well, aptly named. Here we can see how much of the negative predictions we did correctly. So basically how many people under 50,000 that we predicted correctly, and the people above 50,000 that we predicted correctly, and then these two numbers are the ones we got wrong. Overall, we have an 87% average correctness, and that's really good. For the next part, this is for the people that want to take it a step further. This is common practice in machine learning algorithms. But what we want to do is we want to make sure we're getting the best result from the cutoff. We don't want it to just be arbitrary. We want to find the best cutoff for our model. We're going to iterate through all the cutoff points between 0 and 1. Let me write the code before I explain it. So as I said before, we're going to iterate through the cutoffs ranging from 0.01 to 1, and we're going to do it in increments of 0.01. We're going to calculate the log loss. Log loss in simple terms is the error or uncertainty of our model. In a perfect algorithm, that log loss would be 0, so we want to get it as close to 0 as possible. This loop just calculates the log loss for each cutoff as it goes through, and then we'll build out a graph to visualize that. So as you can see here, these are the different cutoffs, starting from 0.01 all the way to 1. We want to find the point where it's the least value of log loss. So while we can just eyeball it, we obviously want to make sure there's no error for that. So what we're going to do is create a simple script to tell us what the minimum value of this graph is, and that's 0.53. Then we can rerun the code again from before, which repeats our cutoff at 0.53. Okay. And we can see if there's any difference. In our case, there wasn't, but in a majority of cases, there would be. We can also go back and look at our algorithms, see what else we want to change, make sure our hyperparameters or our settings or even our instance could be changed. We use the default XGBoost, but there's definitely a better model for this that can get us to a higher accuracy. Once you're done, we just clean up, and there we go. We have our first machine learning model.